This is section 6.5. We're going to be factoring and solving polynomial equations. Homework assignment is 53 through 70. In general, if you're going to be factoring, that's kind of like a four-step process. First thing you always want to do is factor out the GCF. Always factor out GCF. Look for the GCF if possible. For example, if I have 4x squared plus 2x, you look to see what they have in common. For the numbers, the coefficients, notice they both have a 2. So you would factor out or divide out a 2. For the variables, they both have an x, so you're also going to divide out an x. If you look at the first term, you have 4x squared, and if you're dividing out a 2x, that leaves you with 2x. And the second term, if you have 2x and you're dividing out a 2x, you're left with a positive 1. So, in general, when you're factoring, first thing you always look for is GCF. Second thing you're going to do is count the number of terms. If you have two terms and it's a subtract, check to see if it works with the difference of squares formula. So if you have something squared, subtract something else squared, you're going to use this formula right here to factor. For example, I have x squared minus 25. Notice my x is a square. I'm subtracting. And if you look at the 25, you'll notice that I can square a 5 to get the 25. So this fits the formula a squared minus b squared. So when we factor it, remember one has to be plus, one has to be minus. And what we put here is what we had to square to get for the first term. So we squared an x to get x squared. And over here, we put what we had to square to get the 25. So we squared a 5. Answer, x plus 5, x minus 5. Something new, so that's all review. We've done that before. Something new, if it has two terms, it might fit this pattern right here. It could be a cube with a plus. If that's the case, you are going to use the sum of cubes formula. So first thing you have to do is figure out what you have to cube to get x cubed. You had to cube the x. And you have to figure out what you had to cube to get the 8. Well, 2 times 2 times 2 is 8, or 2 cubed is 8. So my a in this case is x, and my b is 2. So you're going to take your x and your 2, and you're going to plug them into this formula right here. So my a was x, my b was 2. My a was x, my a was x, my b is 2, and my b is 2. It's not a lot of simplifying, but you do have to simplify. Normally we don't write that as x times 2, we write that as 2x. So final answer, x plus 2, x squared, negative 2x, and 2 squared, which is 2 times 2, which is plus 4. Now, if you're doing the difference of cubes, that's this one, it's the same formula. Same formula with two exceptions. Instead of doing a plus b, we do a minus b. And instead of a squared minus ab, we do a squared plus ab. Other than that, it's exactly the same. So we had to cube the y. We had to cube a 4. 4 times 4 times 4 is 64. So we have y minus 4, y squared, plus We're going to do y times 4, or I'm just going to write 4y, plus 4 times 4 is...
Mr. Chemitra, please dial extension 4000. Mr. Chemitra, please dial extension 4000.
4 times 4 is 16, so I'm going to write plus 16. If you do not have a binomial, if you have a trinomial, or 3 terms, you can use the AC method, you can use the box method, however you choose, it's your choice. 4 terms is always by grouping. So let's suppose we have 18x cubed minus 6x squared y plus 10xz cubed. First thing we want to do is check for GCF, greatest common factor. What do they have in common? So we're going to look at the coefficients first. If we look at the 18, the 6, and the 10, what do they have in common? What's the largest number they have in common? That would be 2. Largest number they have in common is 2. Now we're going to look at the variables. We've got an x cubed, an x squared, and an x. So the largest one that they all have is x. They don't all have y, and they don't all have z. So my greatest common factor will be 2x. We're going to divide that out. So if you have 18x cubed and we're dividing out 2x, you're left with 9x squared. If you have negative 6x squared y and we're dividing out a 2x, 2 goes into negative 6, negative 3 times. And x goes into x squared x times, then I still have the y. And finally, if I have 10xz cubed and I'm dividing out 2x, 2 goes into 10 5 times. The x will cancel with the x, z cubed. Anytime you factor out the GCF, you are going to look inside to see if this is factorable. Since this is a cube, it is not factorable, so this would be our final answer. Example 2. Remember, the first step is always to look for GCF. So if you look at all 4 terms, is there anything they have in common? So we're going to look at the coefficients first. We've got 3, 21, 1, and 7. There is not a number that they all have. Next, we're going to look at the variables. X, nothing. X, Y, and Y. And again, there's no variable that they all have in common. So for example 2, there is no GCF. Next, we want to count the number of terms. Well, you notice it has 4 terms. Anytime you have 4 terms, you're going to factor by grouping, which we have done before, so you guys should remember how to do this. So the first thing we're going to do is look for greatest common factor of the first 2 terms, and they have a 3 in common, so we're going to write the 3 on the outside and divide it out. If we take 3x and divide out a 3, we get x. And if we take 21 and divide out a 3, we get 7. Next, we're going to look at the second set of terms, xy plus 7y. Do they have anything in common? They do not have a number in common, but they do have a y in common. And in fact, since this is positive, we're going to put positive y on the outside and divide out a y. If you take xy and divide out a y, you're left with x. If you have 7y and divide out a y, you're left with 7. Remember, when you're doing this, those two have to match exactly, including the signs. So we're going to divide out the x plus 7. And what is left? We have 3 plus y. Example 3. Check for GCF. Do they have anything in common? Well, they have no number in common and they have no variable in common, so there's no GCF. Count the number of terms. We've got 1, 2, 3 terms. 3 terms as a trinomial. So you can pick your favorite method for factoring a trinomial. I'm going to show you with the box method. Remember, in the upper left-hand corner you put the x squared, in the lower right-hand corner you put the constant, which in this case is a positive 14. Now we're going to check to see what goes on the outside. If you look here, x squared, the only way to get x squared is x times x. Next we're going to figure out what we have to multiply to get the 14. Well, it is a positive 14. So we can either multiply two positive numbers together, or we can multiply two negative numbers together. Since this is negative, it's going to be two negative numbers. I can do negative 1 times negative 14. Negative 1 times negative 14. This would give me a negative 1x. This would give me a negative 14x. And if I add those together, I'm looking for negative 9x, and that won't work. So I'm going to try again. Let's try what else multiplies to get 14. Let's try negative 2 and negative 7. So negative 2 times x will give you negative 2x. X times negative 7 will give you negative 7x. And if I add those together, that will give me a negative 9x, which is what I'm looking for. So my factors, x minus 2, x minus 7. Example 4, I'm going to have you do on your own. And example 5, I'm going to have you work by yourself. Let's look at example 6. First thing we want to do is check for GCF. Do we have anything in common? And the answer is no, we have no GCF. So now we're going to count the terms. We have 2 terms, which makes it a binomial. So we have 3 options for binomials. It can either be a difference of squares, it can be a sum of cubes, or it can be a difference of cubes. Since this is subtract is difference, so it's either going to be a difference of squares or a difference of cubes. And you look here and I have x squared. Well, that tells me that I need the difference of squares. So what did I have to square to get x squared? And what did I have to square to get 49? Don't forget, one has to be plus, one has to be minus. I'm going to have x plus 7, x plus 7, x minus 7. All right, let's take a look at example 7. I'm going to have you do that on your own. Example 8, look for a GCF. They can both be divided by 3. So I have x squared minus 25. We have a binomial inside. This is a square, and this is a square. X plus 5, x minus 5. I'm going to stop here for the end of this video.